Welcome back to Anton Math. And before we start talking about even and odd trigonometric functions, I want to do a very brief review about even and odd functions in general. Right? I know it's probably been a little bit since any of you have seen this, so I want to look at even versus odd functions. Now the first thing I want to note before we get into this, not all functions are even or odd. This is a very important thing to note. Okay? There are all whole numbers are even or odd, but to give you an example, not all numbers are, right? 1.5 is not an even or an odd number. So not all functions are going to be falling into one of these two categories, but we want to talk about what a function looks like if it does fall into one of those categories. Now I'm just going to look at a general function. We know our kind of general notation for a function is just f, right? Now this f, when we're talking about trig functions, this is the same as sine, cosine, tangent, cotangent, etc. This is just a function. Those are specific functions, but this is our general notation for any function. Now if I have f of negative x, and that is the same thing as f of positive x, we call this an even function by definition. Right? If whenever you plug in a negative value and a positive value into the same function, you get the same value, it's an even function. Now, if I have f of negative x is equal to negative f of x, this is what we call an odd function. And when we get into graphs, this will be a little bit useful. Even functions happen to be symmetric over the y-axis, and odd functions are symmetric over the origin. But we'll get into that a little bit more later. Now for trig functions, let's look at some of these. Okay. Let's look at sine. And we'll use the unit. I've left the unit circle up here because it's going to be a little bit useful for us. If I have sine of negative t, I want to compare that to sine of positive t, and I want to see what the correspondence is here. So let's take some arbitrary t. Let's say that this is my t. Well, then this down here would be negative t, wouldn't it? Now I know that sine is my y value, and it's easy to see here that whatever my point is here, if this is p x y, then this point down here is going to be p. It's going to have the same x value, isn't it? I could draw a little line here. This has the same x value. And we know that if something has the same x value, just a little review from that first section of unit circle, plugging that into our equation for the unit circle, I have a plus and minus y solution that's going to match up with this x. But that's it. I either have this plus y or this minus y. So if I have a point with negative t, this has to be x negative y, doesn't it? So in this first one, I should be a little bit more specific, sorry. I didn't mean to call this p. This is a different point, right? And we know if we have a different point, we use a different letter. So I'm going to call this q. This is q of x negative y. So sine of negative t is going to be the same thing as negative y in this case, right? And I know that y is just sine of t. So this is the same as negative sine of t. So sine, is it going to be even or odd? Well, looking at my definition here, I have f of negative x equals negative f of x, means that I have an odd function. Right? So sine is an odd function. Cosine of negative t, we can see by my little diagram up here, cosine stays the same, doesn't it? Because I'm going directly above or below, because my initial point's on the x-axis. If my initial point were up here, we'd be having a different conversation. But this is the way that it's going to work here for cosine. No matter if I'm going in a clockwise direction or a counterclockwise direction, as long as I'm going the same distance in either direction, I'm going to end up with the same x coordinate at my terminal point. So cosine of negative t, this is equal to positive x, which is the same thing as positive cosine of t. So cosine of t is going to be an even function, isn't it? I want to look at tangent. Now again, this is going to correspond to those secondary functions, right? Sine and cosecant have these same properties, cosine and secant, tangent and cotangent. So let's look at tangent. I'm just doing it with these three, but you can apply this same kind of analysis to those other three functions. Tangent of negative t, looking at my point Q down here, with a negative t, that's going to give me, corresponding to a positive t, of course. This is a relative information. Tangent of negative t is going to be negative y over x, which is the same thing as negative the entire quantity y over x. And then by definition, this is the same thing as negative tangent of positive t. So tangent, just like sine, is going to be an odd function, as is cotangent. Now, why is this useful? Well, let's just say I want to cut out a little bit more of the work that I'm doing with these reference numbers. Okay, let's see if I can fit this in here. Make a little box. Do my example over here. So let's just say I'm trying to figure out, for example, sine of negative pi over 6. Now I could look up my reference number, it's pi over 6, and then I could figure out what quadrant I'm in to find out if this is going to be positive or negative, or I can use the fact that sine is odd and say, well, this is the same thing as negative sine of positive pi over 6. Because sine is an odd function, I know that this is true. And I know that sine of pi over 6, well, sine of pi over 6 is just 1/2. So this negative stays out here, and this sine of pi over 6 is just 1/2. Right? So I've cut my computation time down just a little bit more, haven't I? I don't need to use pi over 6 as a reference number necessarily, because once I pull out that negative, using the odd property of sine, my t is pi over 6. Right? And then I don't have to worry about what quadrant I'm in order to find out whether it's positive or negative. Similarly, I could have something like cosine of negative pi over 4. Well, cosine's an even function, so cosine of negative pi over 4 is the same thing as cosine of positive pi over 4, isn't it? Again, I don't have to worry about what quadrant negative pi over 4 is in, because I know what cosine of positive pi over 4 is. It's the square root of 2 over 2. All right, I hope this was helpful. In the next section, we're going to be talking about our Pythagorean identities. This is the last topic we're going to be talking about here in Unit 2.